Okay, so far we have seen different ways we can store data in NumPy arrays, how we can create them, how we can access those values, how those values of datasets, how we can reshape them, how we can change their orientation, dimensions, and size and shape and whatsoever. So far we have dealt with the data storage and data manipulation. Now we're going to talk about the computations we can perform on NumPy arrays. For that, we're going to use universal functions. Before we move on to these functions, it's important to understand why do we need these functions as well. So the basic concept is that vectorized operations versus loops. The thing is that Python loops are slower. Actually, all loops are slower because we have to iterate through every value, and let's say it's rather easy and comprehensible when we're talking about smaller or shorter arrays, but imagine if we have hundreds or millions of sizes of data and you have to iterate through over that data using a loop. It will take as much as time as the size of the data. So we need to have a faster way of doing that, right? For that, we need to to reduce the cost, we need to have a better operation. That's why NumPy provides us with a vectorized approach of using ufuncs. So the universal functions are actually a vectorized approach, which is a better approach than loops. That's why they are better, mostly you can say computationally efficient whenever we're using them, and it helps us a lot whenever we're doing computations on large data sets, and it gives us a lot of faster execution, and it's rather very important. So let's talk about some of the universal functions. We have addition, subtraction, negative, multiply, divide, floor divide, power, and mod. We're going to see, okay, some of the universal functions are quite self-explanatory from their names, and some of them need a little bit explanation, but we'll see. So the floor divide over here is that it gives us the value of the, you can say, if we're dividing 3 by 2, the answer should be 1 because that is the lesser value as compared to 1.5, because the actual value is 1.5, but we need the floor value. So in order to remember that, the floor value, we're talking about the lesser value, the lower bound, and the lower bound over here should be 1 and not 1.5. np.power, it's quite simple, np.mod. So np.mod, but mod is different from division in a way that division gives us the quotient and the mod gives us the remainder. That's why it's also called the modulus, and it always gives us the remainder of a particular division. So 9 modulus 4, if you divide 9 by 4, it would give us the quotient of 2.5, but let's say the remainder of that would be 1. 4 2s are 8 and 9 minus 8, 1. Okay, so modulus gives us the remainder and division gives us the quotient. Okay, so let's start with simple functions. We are going to create an array of x ranging from 0 to 3 values. We're going to add constants. So the first thing, we're going to add constants to arrays. These are the most simplest operations. If we have an array, we're going to add 5 to it, and the answer should be that every value of the array should have an addition of 5, and every value of the array should have a negation of 5 and a multiplication of 2, and so on and so forth. So if we're adding, multiplying, or dividing constants with arrays, the operation will be applied to all other values in an array. So let's talk about NumPy aggregation functions. These functions enable us to perform, you can say that we can perform certain functions on the array itself. Okay, so let's talk about some of them. So the first one is npSum. What it does, that it sums all the values in an array. Quite simple. And there is min max value, which gives us the maximum and minimum values in the array, which is also quite useful. And finding minimum maximum value across x's. Now this is something we need to understand. What do we mean by finding min max values in array across x's? Let's look at an example in order to get a better sense. So in the above figures, we have a 2D array, and if we want to find the max value, and the max value is 6, quite simple. It doesn't matter if it's a 2D or 1D array, it will search throughout the array and it's going to give you the maximum value for it. And the minimum value does the same thing. The sum function adds all the values regardless of their orientation in 2D or 1D array. Now let's talk about x's. Now we have data.max, and the axis parameter to this max function is 0. What it does over here is that it gives us the two values. It gives us two values of 5 and 6. Now let's look at this green arrow. This green arrow tells us that this is the axis direction when we're talking about axis 0. And axis 0 is actually the y-axis. So downward, we're going to look at columns if we're talking about 2D arrays. And axis, the concept of axis can only be applied to 2D arrays. It cannot be applied to 1D array because in 1D array, we only have one axis. So in 2D arrays, axis 0 tells us we have to find the largest value in each column and represent it. And the same concept, vice versa, can be applied to axis 1, which tells us that you need to find the largest value in every row of the 2D dataset and then give us that. So the answer is not, you can say, it's not a single value, it's rather an array itself. So this tells us another important and beautiful functionality, that we can actually extract more data in the representation of arrays of NumPy if we apply aggregation functions.